Welcome to Chapter 6, Lesson D, Lesson 4, somewhere around there. So if you have a different base logarithm, we talked a little bit about this, what we can do is we can exponentiate. So if y equals the log base b to the power of x, you can basically take the b and move it underneath the y and get rid of the log. So this only works if b to the power of y equals x. Again, the way that I learned to do this was showing my work by exponentiation. So if that's a base b right there, then everything becomes a power of b. And a b with a power is the opposite of a log with a base b, so those cancel each other out, and that's another way you can show your work for b to the y equals x. So this is both your notes and your homework. So we're going to do a couple of these, and then I'm going to leave you the rest. But if the log base 2 of x equals 3, then again we can turn everything into a power of 2. Again, this 2 and the log base 2 are designed to cancel each other out. Now this basically just says that x equals 2 to the third power. 2 times 2 is 4, times another 4 would be 8. Same thing works if you've got fractions, either as your base or as your exponent. So if I have a log base 1/3, then everything can become 1/3 to a power. Again, those cancel, so x equals 1/3 to the fourth power, which is really 1 to the fourth power over 3 to the fourth power. So x really equals 1/81. Again, that works whether your base is a fraction or your exponent is a fraction. I might have to tighten up this joint at some point in the future because my projector is, or my camera is a little loose. But same idea here. The 1/2 power, or the 1/2 is now going to become a full power of 4 right now. So now we have x equals 4 to the 1/2 power. And again, 4 to the 1/2 power is really the second root of 4 to the first power, which is really just saying the square root of 4. So that means that x is 2. Another thing about logs is that logs can only have logs can only have positive numbers. Not even 0 works inside a log. So this x has to be positive. There would have been a negative sign out here if they wanted this to be possibly a negative too. Part D, log base -8 equal to the x power equals 1/3. So everything is now going to become a power of -8. Again, -8 is the whole thing. So x equals -8 to the 1/3 power, or the cube root of -8 to the first power. Again, -8 could really be -2 times -2 times -2. And then those would undo each other, so x has to be -2. Part E, you might notice that the x is totally by itself. So we could try this saying that 4 is now the new base, so 16 equals 4 to some power. And then we would just approach this the same way that we were before. 16 is really 4 squared equals 4 to the x power. So the two powers must be the same. Or again, we could have used that change of base formula that we talked about previously, or in the last video, where the log base b of a number you can use in your calculator as the log of that number divided by the log of the base. So we could have said that x equals the log of 16 divided by the log of 4. If we look at that here, log 16 divided by log 4 is still the 2 that we got. So that's pretty much all the tricks that you're going to come up against. Again, same kind of trick. It's going to happen in F here. You could do either approach for F as we did in E, and the rest of the back side of this is also your homework for tonight. So see what you can get with these.